Okay, good morning, everybody. So I'm going to pick up from where we left off last day. Sorry, just let me adjust the volume here. Okay, and we'll continue talking about how to make a class. So when you create a header, the first thing you do is you declare, when you make a method, the first thing you do is you declare the method. So that first line that you write, that's sometimes called the header of the method. And that header is made up of the 5 parts, up to 5 parts, although we don't really see part 5 in this course. So you have modifiers, return types, method names, and parameter lists. So I'm just going to show you each part on a separate slide. So the modifier determines the visibility of the method. The modifier, an access modifier, determines the visibility of a method. There can be other modifiers here as well. So for example, the method could be static, in which case it indicates the method belongs to the class. And there are a small number of other modifiers as well, I believe. The next part of the method header is normally the return type. So this is just the type of value that's returned by the method, or void if the method returns no value. Then there is the name of the method. So when you pick the name of the method, it normally begins with a lowercase letter, and then the rest of the name is formatted in lower camel case. So if it's a multi-word name, you should start each word each word after the first with a capital letter. And then finally, inside the parentheses is what's called the parameter list. So the parameter list is just the list of types and parameter names. So these are the arguments that the method accepts. So that thing there, the parameter list, the names in that list have to be unique. So you can't have 2 parameters named x in this list, for example. Right? The scope of the parameters are the scope of the method body. So in Java, every method has what's called a signature. So the signature of the method is the name of the method, followed by the types of the parameters in the order that they appear. Right? So the set method has the signature set double double. Now the signature is the part that's actually important. So more examples of signatures from the standard library. So in string, there's a method to uppercase. Right? It has no parameters, so its signature is just to uppercase. Char@, has an int parameter, so its signature is char@int. And I guess the last one, getChars, has an int, an array of char, and an int. So its signature would be getChars int char, array of char int. Right. So it's the signatures in the class that have to be unique. So which means you're allowed to have 2 methods with the same name. Oh, sorry, here's you cannot. This is an example where, so I can have a method called set. Right, so here we have one that's set double double. So I'm allowed to add another method set that also has a parameter that's a double. That's fine. It has the same name as the previous method, but its parameter list is different, so its signature is different. What you can't do is you can't add a third method with the same with a signature that's the same as one of the other 2. Right? So I can't add the method set double y. The parameter names don't matter. It's only the types that matter. Right? So 2 methods in the same class, multiple methods in the same class can have the same name, but the parameter lists must be different. Here's another example. I don't think these are actually in the point2 class, but if you wanted to, you could put these in. So if you wanted to compute the distance to a second point, right, where the second point has coordinates x, y as 2 floats, or x, y as 2 doubles, or as another point, right, you can add all of these methods to the class, and everything would be fine. Right? They have the same name, but their parameter lists are different. So these are all acceptable inside the class. When you have 2 methods with the same name, they're called overloaded methods. Right? And it's very common in Java for a class to have several overloaded methods. The return type is either, so a Java method returns either something, so one return value, or it returns void. Right? So our method x returns a double. Okay, so just let me quickly jump ahead here. Okay, so in Java, in Java there are methods that you can use for all objects. Okay, so it doesn't matter if you create the class yourself or if you're using a class from somewhere else. Right? So the way this works in Java is that in Java every class is what's called a child class or a subclass or a child class or a subclass of this thing called java.lang.object. Now what that means is that every method that's in object is also in every other class. Right? So in total there are 11 of these methods. Right? So in other words, it doesn't matter what object you have, there's at least 11 methods you can call with this object. Most of those aren't relevant to this course. 3 of them though are important to us. Right? So there's toString, there's equals, and there's this thing called hash code. Right? Now equals we've seen already. Right? So equals we've seen in string, in the string class, right? So where I told you if you're going to test 2 strings for equality, use the equals method. Well, that's true for all reference types. Right? If you want to test if 2 reference types are logically equal, then you should use the equals method. Right? ToString is the method that makes print line work. Right? So you can pass any object to either print or system.out.print or system.out.println, and it will print the object. Right? The reason you can do that is because every object has a toString method that takes the object and produces a string representation of the object. Hash code we'll look at in a separate lecture. Okay, so when you create a value type class, it's often useful, especially for debugging or other purposes, to be able to print the state of the object. So for example, for our point class, right, it might be nice that if you tried to print, when you printed the point, you got something that looked like that. Right? So that would be the way a mathematician might write a point. Maybe. They might write it a different way. And so you can provide this ability by overriding the toString method. Right? Okay, so that means I can go into the class and I can add a method called toString. Right? No parameters here. Right? So toString never has a parameter. It always returns a string, and it's always public. Right? So if I want to generate the string representation of a point, so that it looks like that, right? Then it's pretty easy. Right? You start with an opening round bracket, you end with the closing round bracket. Right? That's just the x coordinate as a string. There's a comma, then a space, and then that's the y coordinate as a string. Right? So it's very easy to implement this method. You start out with the opening round bracket, right? Then the x coordinate. So you just concatenate the x coordinate with the opening round bracket. Right? Then you concatenate the comma and the space. Then the y coordinate, then the closing round bracket. Right? That produces a string which you can return. Okay, so when you redefine the way that a method works, like toString or equals or hash code, right, you're allowed to add this funny override, this tag here that reads @big-O override. So this thing here is called an annotation in Java. Annotations are treated specially by the compiler. So in other words, the compiler will notice that there's an annotation here, and it will do something depending on exactly what that annotation is. So the @override annotation, it's optional, so it doesn't have to be here. Right? So in other words, if you left it out, this would still be fine. But if you put it in, the compiler will check, is there actually a method public toString that returns a string inside the class big-O object? Right? If there is, then this is fine. Right? So if there is a method public string toString in the class object, then the compiler knows that you're replacing the definition that you got from object with this definition here. Right? If you make a mistake, so if you change this to say protected, or sorry, to private, or if you change the string here, the return type to something else, so if you made it void or something like that, or if you misspell the name, or if you add a parameter incorrectly, right? The compiler will flag that as an error as long as this tag is here, right? So if you make a mistake in the header of the method, right, the compiler will flag that as an error and tell you, hey, you're trying to override this thing called toString, but there's not actually a method with this signature in the class that you're overriding. Okay, so if you provide a toString method, then anybody using your class can now print points, which is nice, right? It's handy. So for example, you can write a little class called printPoint, right? Put in a main method, make a point, change its coordinates to -1 to 1.5, and then print the point. Right? So you can write p.toString, right? That takes your point, gives you back the string representation of the point, which can then be printed. You actually don't need the toString. Right? So if you leave out the toString, this will work just fine. So if you do system.out.println p, everything will be fine. The println method will automatically call toString on the reference for you. Right? So you can pass any reference to println. Right? Println will automatically call toString on that reference and use the string representation returned by toString to generate the output. Okay, so there's a few methods in the point2 class. Right? So now we can go into the counter class and also add a bunch of methods. Right, so remember our counter class, it's just this thing that counts starting from 0, going up by 1 every time. Right? So in order to make the class usable, you have to provide some methods. Right? So for example, it would be useful if somebody could actually get the count that the counter is holding. Right? You want to be able to advance the counter by 1, so ask the counter to go up by 1. You probably want to get the string representation of the counter as well. And so these methods are fairly straightforward to implement. Right? So remember our counter class, all that it has is this int value called value. Right? It has a constructor that sets the value to 0. Right? And now I want to add a method that gets the current value of the counter. Right? So our method's called value. You'll often see these methods called getValue or something like that. So often you'll see accessor methods start with get. You'll see mutator methods start with set. That's not always true. So in this case, the method value simply returns the value. Right? So it has to return an int. It's easy to implement. You just return the value of this counter. Right? So just return this value. To advance the counter by 1, you have to decide exactly what happens when you hit the highest possible value. Right? So this method says it increments the value of the counter up by 1. Right? If the method is called when the current value of the counter is integer max value, then the value of the counter is set to 0. Right? So it wraps around, but it doesn't wrap around like an int wraps around. Right? An int would wrap around to integer min value. So for the counter, it wraps around back to 0. So again, this is pretty easy to implement. Right? So you test, is the current value not integer max value? Right? If it is, you can safely add 1 to it. Right? If it is integer max value, then you just set it to 0. What you don't do in this method is something like the following. Right? So this is surprisingly, well, it's very common to see the method written this way. So often you'll see something like this value plus plus, like that. So they'll automatically, we automatically increment the counter by 1. Then you try to test, right? So if this value is greater than integer max value, this value equals 0. Right, so that's not, so ignore this part up here for now. So this is not unusual to see for someone new to programming in Java. Right, so what this does is it takes the value and automatically adds 1 to it. Right? But if the value of the counter is already integer max value, this immediately wraps around to a negative value. Right? So in other words, you can't test. This test here makes no sense. Right? The value is never greater than integer max value. Right? Integer max value is the largest value that an int can hold. So this statement's never true. Right? So you have to test, right? Can I actually increment the value first? So don't do that. So So you have to test, can you safely increment the value? And if so, go ahead and do so. Right? Otherwise, wrap the value around to 0. All right, so toString is also straightforward in this case. Now there's, when you implement toString, there's no rules for implementing toString. Right? You have to decide on what's an appropriate string representation for your object. So for the counter, I've decided that I'm going to, the string representation will have the word count, then a colon, then a space, followed by the actual count. Right? So count colon space, and then followed by the actual value. Right? Now, you could choose a completely different representation here, and it'd be perfectly fine. Right? So you could do square brackets, then the count, or you could put the count inside of braces, or inside of round brackets, or whatever you want. Right? So there's no, again, there's no convention for how you generate the string representation of an object. Right? It really is up to you. All right, now what about the stopwatch class? So remember our stopwatch class, this represents a stopwatch where you can start and stop the stopwatch, and you can ask for how much time has elapsed since you pressed start. Right? So when you ask for the elapsed time, right, if the watch is running, then the elapsed time is the time from when the watch was started until now. Right? And if the watch is not running, then the elapsed time is the time from when the watch was started to when it was stopped. Right? So just like a real stopwatch. All right, so here's our stopwatch class again. Remember, we're keeping track of the start and stop time, and we're going to use system nanotime to get those times. Right? And we also are keeping track of, is the watch running or not? Here I've got a constant called 1 billion because I want to convert nanoseconds to seconds. Right? So that's just the number 1 billion. So I'm just going to multiply the elapsed time by 1 billion to get the time in seconds. Our constructor sets the start time, stop time to 0, and sets the is running to false. Okay, and now we have our start method. Right? So the start method needs to set the start time, right? And it needs to set is running to true. Right? But it should only start the start time if the watch is not running. Right? So in other words, if the watch is already running, calling start should do nothing. Right? So if the watch is not running, right, set the start time using system nanotime, right, and then set is running to true. Right? If the watch is already running, it does nothing. Okay, now what about stop? So the stop method up here, I guess, so stop stops the stops the stopwatch and returns the elapsed time in seconds since the watch was started. Right? So if the watch is already stopped, right, then the elapsed time is just the time between when the is just the total elapsed time for the watch. Right? So I'm going to use this method called thisElapsed to return the elapsed time. All right, so if the watch is running, then we have to stop the watch. Right? So to stop the watch, you set the stop time. Right? Again, you just call nanotime, and then you set is running to false. Right? Now, regardless of whether or not the watch is running, we're going to return the how much time has elapsed. Right? So that's what the elapsed method does. Right? So a method can call another method in the same class. Oops, sorry. All right, so the elapsed method. For a running stopwatch, the method returns the total amount of time in seconds that have elapsed since the stopwatch was started. Right? For a stopped stopwatch, right, the method returns the total amount of time in seconds that elapsed between starting and stopping the watch. Right? So notice elapsed returns a double. Right? So in other words, it's going to return some number of seconds, so something point something 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 seconds. All right, so elapsed is a bit funny. Because someone can call elapsed without stopping the watch. Right? So if they call elapsed without stopping the watch, you need to know what is the current time. Right? So that's what current time is here. Right? So ask nanotime for the current time. Right? Now if the watch is not running, right, then you actually want the amount of time between the stop time and the start time. Right? So what I'm going to do is I'm going to set current time to the stop time if the watch is not running. Once you have the current time, you can now compute the elapsed time. Right? So the elapsed time is just the current time minus the start time divided by 1 billion. Here we have to add 0, though, 0.0 to the front, to the value at the front. sorry, you have to add 0.0 to the value in the numerator. Right? Because if you don't, right, current time and the start time, these are both long. Right? So in other words, they're both integer types. Right? So if you take a long and divide it by a billion, which is also a long, you end up doing integer division, right? Which won't give you the correct. It'll give you the number of seconds, but it won't give you any. It won't give you the fractional part of the elapsed time. So to compute this as a double correctly, you have to make sure that either the numerator or the denominator is a double. So here I've chosen to make the numerator a double by forcing the arithmetic to be done using double arithmetic. Right? You could put a cast in here as well. So you can write round bracket double, closing round bracket. Right? That'll cast current time to double, and then the rest of it will be done as double. Right? You could compute the top. Can you safely compute the top? I think you can safely compute the top as current time minus the start time, and then convert the denominator to double as well. All right. Any questions so far? Yes. Can you do integer division with? No. You mean, can you do integer division with float? Is there a way to do it? I don't. I'm just trying to decide if there's a method in math that does it for you. And the answer is I don't know if there's one in the math class. Do I have a web? I do. If there's a way to do it, it's in math. Absolute. No, I don't think you can. So if you want to do integer division with two double values or two float values, how would you do it? You would have to round the float values to some integer type, and then do the division. Okay, back to constructors. So a class is allowed to have. A class is allowed to have multiple constructors. Right? Now, constructors, just like methods, they have signatures. Right? So with constructors, the constructor name is always the same. So the signature of a constructor is determined by its parameters. Right? So that means each constructor must have a unique list of parameter types. So for all of our classes so far, we only have the no argument constructors. So let's go ahead and add more constructors. Right? So for point 2, it makes sense that the user of the class is going to want to make a point with a specified x and y coordinate. So add a constructor has a specified x and y coordinate. Right? So this is an example of where you must write this dot x and this dot y in front of your fields. So our constructor here takes in the x coordinate and the y coordinate of the point. Right? But notice here, the parameter x is the same name as the field x, and the parameter y has the same name as the field y. Right? So this is fine in Java. So what happens inside the constructor? So inside the constructor body, if you write x, then you mean the parameter x. And if you write y, it's the parameter y that's used. Right? So in this case, if you want to set the field called x, you must write this dot x in front. Right? If you think about it for a second, this is the only thing that makes sense, because otherwise you'd end up writing x equals x, which does nothing in Java, right? And you end up writing y equals y, which also does nothing. Right? So to set the to set the fields, it's this dot x equals x and this dot y equals y. Right? Not the also surprisingly common to see x equals this dot x and y equals this dot y. Right? That changes the parameters x and y, which you don't want to do in this case. Right? You want to assign a value to the fields. We've seen this picture before. Right? So this is just what happens when you call the constructor. Okay, so inside that constructor, the name x matches the field name x, the name y matches the field name y. When this happens, the parameter has precedence over the field. Right? So in other words, again, inside the constructor body, x means the parameter x, y means the parameter y. In the Java says that the parameter shadows the field, right, or hides the field. Right? So when shadowing or hiding occurs, you have to use this in order to access the field. It turns out this happens quite a lot in Java. So it's quite common for people to create methods or constructors where the parameters have the exact same name as the fields. Why add this constructor? Because now people can more easily use your class. Right? Oops, sorry. Okay, so before, in that, so there was that print point example, right? We made a point 2 object, right? Its coordinates were 0, 0. Then we had to change the coordinates using set, and then we could print the point, right? Now that we have this constructor, right, you've saved the user that extra step, right? So instead of writing that, you can just write that now, or the user can just write this, right? They can create a point, they can initialize the point to their whatever coordinates they want, instead of always getting a point whose coordinates are 0, 0. Right, so this makes the class much more pleasant to use. Right. So we can keep on adding more constructors, right? So there's something called the copy constructor. A copy constructor initializes the state of an object by copying the state of another object of the same type. Right? So you can identify a copy constructor because it always has one parameter, and the parameter is usually the exact same type as the class. Right? So in other words, the point2 copy constructor, right? Its name is point2, and its parameter is also a point2 object. Right? And so here's an example of where we're going to use another point2 object, right? And we're going to access its x and y fields directly. Right? So to change, or to initialize the coordinates of this point, right, we write this x equals other.x. Right? We're allowed to access the field x belonging to other, right? Because the type of other is point2, and we're inside the point2 class, right? So even though x is private, right, we're inside the same class. So within the class, we're allowed to access the private features of another point, right? So we can write other.x here instead of having to call the method x, right? So there's also a method called x, which is public, but you don't have to call the method. You can just access the field directly by name here. Right? And similarly, it's this.y equals other.y. Right? Whatever you do here, don't flip the order around. Right? Don't write other x equals this x and other y equals this y. Right? That ends up changing the coordinates of the other point, right? Which you really don't want to do here. Right? The purpose of the constructor is to set the fields of this point. Right? So it's always this x equals something and this y equals something. Why add a copy constructor? Again, because it makes your class a lot easier to use. Right? So up here, we can make a point, right, using our new 2-argument constructor. Right? We can then copy that point just by calling the constructor. Right? If we didn't have the copy constructor, we'd have to make a new point. Right? Using, we'd have to do it in one of 2 different ways. Right? So without the copy constructor, you would have to write something like, sorry, that's going to be hard to read. You'd have to write something like point2 q equals new point2 p dot x p dot y. Sorry. Right? So instead of forcing the user to call some method on p, right, to get the x and y coordinates, right, with the copy constructor, you just pass in p and let the copy constructor do the work for you. Right? So it makes your class a lot easier to use. So let me get rid of, so let's get rid of that. Okay, when you use the copy constructor, right, you end up with a new point. Right? So p and q, they are new and independent points. Right? If you change p, q doesn't change. Right? So if I change p to 99 and 44 and then print p and q, right, p changes to 99 and 44, but q stays as -1 and 1.5. Right? So now you've got 2 independent points whose coordinates can be changed independent of one another. Oops, sorry. All right, so all of our constructors, if you go back and look at them, they all do the same thing, which kind of makes sense because that's the job of a constructor. Right? Every constructor is supposed to initialize the state of the object. How does it do that? It sets the fields of the object. right? So that means for our point2 class, all of the constructors are going to be this dot x equals something and this dot y equals something, right? And what does that mean? It means there's a lot of code duplication happening, right? So whenever you see duplicated code, right, you should have been taught in 121 or 101 that you should just write a method and call the method, right, to avoid duplicating that code. Right? When you're writing a constructor, it's typically the case that one of your constructors is the most general constructor. Right? So let me show you what I mean by that. Right? So this constructor here is the one that actually takes in two coordinates x and y. Right? So I could just use this constructor for everything. Right? Now, is there a way for the first constructor to call that constructor, and is there a way for the third constructor to call that constructor? Right? And the answer is yes. Right? So the answer is, so a possible solution is to use what's called constructor chaining. Right? So a constructor is allowed to invoke or call another constructor. Right? And when you do so, that's called constructor chaining. Okay? To invoke a constructor in the same class, right, unfortunately, you also use the keyword this. So this gets recycled. So it has another meaning, in other words. Now, if you're going to use constructor chaining, right, so in other words, if you're going to call another constructor in the same class using this, right, then it must happen on the first line of the constructor body, right, which is limiting sometimes. Sometimes you have to do some validation, and you want to do the validation on the first line of the constructor. If you're trying to use constructor chaining, that doesn't work anymore. Right. Okay, so if you want to do this, then it has to happen on the first line of a constructor, and you cannot do this inside of a method. Right? So a method cannot invoke another constructor using the this keyword. Right? So how do you do this? Well, it works as follows. Right? So our no argument constructor should set the coordinates of the point to 0, 0. Right? So instead of writing this x equals 0 and this y equals 0, I'm going to call the second constructor. Right? So you call the second constructor with the keyword this, and you pass in the two arguments for x and y. Right? So in other words, we just call the second constructor with 0 and 0. For the copy constructor, right, I want to set this x to other x, and I want to set this y to other y. So I can reuse the second constructor by calling it, right, and passing in other x and other y as the arguments. Right? And so that's an example of constructor chaining. Right? In this example here, it doesn't save you much work. Right? It saves exactly 2 lines of code. Right? It saves 1 line of code here. It saves 1 line of code here. Right? So in this particular example, it doesn't look particularly useful. Right? But if you have a class that has many fields in it, then this becomes enormously useful. Right? It can save you a lot of code reuse. All right, so back to the counter class. Right? So we can add additional constructors to the counter class. Right? So for example, instead of starting the counter at 0, the user might want to start the counter at some other value. Right? So we can add a constructor to let them do that. And we can add a copy constructor as well. Right? Furthermore, we can use constructor chaining to minimize code duplication. Right? Now in this case, constructor chaining really doesn't help. Right? Because there's only 1 line in the constructor bodies. Right? So for our no argument constructor, we're going to change it to use constructor chaining. Right? So I'm going to call some other constructor that takes in the value of the counter. Right? Now, for the value of the counter, right, our constructor takes in an integer value. Right? But remember, our counter doesn't let the value go below 0. Right? So in other words, it always starts at 0 and counts up. Its value is never 0. Is never negative, sorry. So if you're going to provide this constructor, right, you have to validate the input argument. Right? If that value is less than 0, then it's not a valid counter. Right? So if our value is less than 0, we throw an exception. Right? As soon as you throw the exception, the constructor stops running, right? And the object is not initialized. At least it's not initialized completely. Right? If the value is greater than or equal to 0, you go ahead and set the value. For the copy constructor, right, we just use chaining again, call the second constructor passing in the other value. Right? Okay, so there's a problem here though. Well, there's not a problem. There is a disadvantage to constructor chaining in this example. Right? All right, so back here, when we set the value to 0, right, 0 is a legal counter value, right? So there's no point in testing is 0 legal for the counter, right? When you use constructor chaining, right, we always validate the value, right? So in other words, there's this unnecessary validation here caused by the when you chain from here, right? So here, you're paying the price of this if statement, right, that you wouldn't normally need to call. Similarly here, right, when you copy another counter, right, there's no need to validate other.value, right? If the rest of the counter class is implemented correctly, then the value of the counter is never negative, right? If it does become negative, then there's something wrong with your class, right? But if there's no need to validate this either, right? But when you use constructor chaining, you always end up paying for the validation here, right? Again, and so in this example here, that if statement is not expensive to run, but it's entirely possible that you create a class where the validation is expensive, right? So for example, if you're accessing a database or something, and the validation involves a database access, that could be very expensive, right? And so you want to avoid that, right? Constructor chaining can be used for code reuse. Often it ends up costing you some unnecessary validation. All right, any questions so far with today's lecture? All right, so I guess there's still lots of time, so I'm going to jump ahead to the next deck of slides. Oh, documenting. All right. So assignments 1 and 2, I didn't ask you for any documentation. So that's going to change probably in assignment 3 or 4. Right? So at some point, probably in 121, right, you were told that you should always document your code. Right? I believe that Dr. Meager actually had you use a standard Python documentation, standard way of documenting your Python code. So documenting code is not a new idea, right? So when Java was invented and popularized, right, everybody knew you had to document code. The way you used to document code, though, was you would have to go find a paper manual or some printout that had the documentation for the code that you were using, right? Now Java was born early on in the internet age. So it became the first major language to embed documentation in the code, and it provided a tool where you can go in and extract the documentation from the code, and that would produce a readable online version of the documentation. Right? So the tool that generates documentation from comments embedded in the code is called JavaDoc. Right? So the way JavaDoc works is it reads your code, and it looks for these things called doc comments. Right? So a doc comment can appear immediately before the class, any field, any constructor, or any method. So your JavaDoc comments, they start with slash, and then a star, and then a star. Right? So normally a multi-line comment is just slash star. Right? JavaDoc looks for slash star star. Right? The comment can be written in a subset of HTML. Right? So if you know HTML, then you're allowed to include some HTML in a JavaDoc comment. Right? Typically made up of 2 parts. So you get this description, which is just a bunch of text. Right? The first sentence in the description, that gets copied into the summary section of the documentation. Right? The rest of it goes into the detailed section of the documentation. When you write your documentation, it's often common that you want to break your documentation up into several paragraphs. Right? Now, in Javadoc, you have to put in the HTML p tag to create a new paragraph. The second part of most Javadoc comments is something that begins with an at. Right? So there are these things called tags, like @param, @return, and @throws. There's also many, many, many others that you can use. Right? These are the ones that we care about, though, in this course. Right? So when you Javadoc your class, right, normally you start out by creating a documentation comment for the class itself. Right? So that comment should describe the purpose of the class. So what's our point2 class for? Well, it's a Cartesian point, right? So in other words, it's a point having an x and y coordinate, right? So in 2 dimensions, having real coordinates, right? Typically, this comment will be much longer, right? You'll explain what is the class used for. You might give examples of how to use the class. You might explain or describe what is it exactly that you can do with this class, right? So for example, if you jump into the standard library documentation for, say, the string class, so all of this stuff up here, right? So everything that's here and goes on and on and on, this is all part of the Javadoc comment for the string class, right? So it tells you what is the string class for, right? Or what is its purpose? Its purpose is to represent character strings, right? It then goes on to describe many of the features of the string class, right? It tells you strings are immutable, right? There's even some examples of how to use the string class, right? It tells you or describes broadly what methods the class has, right? It doesn't describe all the methods in detail because you're going to do that later, right? It tells you that you can do string concatenation because that's a pretty important operation with strings, right? And so on and so on and so on, right? So typically, in well-written documentation, the class description is rather detailed, right? What it doesn't tell you in the class description, though, right? So what it doesn't tell you here, anywhere if you look at it, is exactly how is this string class implemented, right? So your documentation is not supposed to describe the inner workings of a class, right? What it's supposed to describe is what is this class for, right? Not how is it implemented, right? It's very common in when you read student documentation that the student goes on and on and on about how they implemented their class, right? None of that should be there. The reason it shouldn't be there is because it's very possible that you're going to end up changing the implementation of the class, right? And now if it's in your documentation, you now have to go and update your documentation to explain what's changed, right? So the documentation should describe what is the class for, not how is the class implemented, right? If you were to run Javadoc on this one comment, the documentation that appears is as follows, right? So you get the name of the class, right? You get it tells you that its parent class or its superclass is object, right? And then it tells you and there is the comment that you just wrote, right? So that sentence there is the same as that sentence that's right there. If there was more documentation here, it would also appear right here. Okay, if you have fields in your class and they're public, then you should Javadoc those as well. Right? So for example, in the math class, right, it's got a public field E and it's got a public field pi, right? If you look at the documentation, if you go and look at the source code for the math class, you'll see it has a Javadoc comment like that and a Javadoc comment like that for E and pi, right? When you run the Javadoc tool, right, those comments appear in the field summary section, right? So you get the name of the field, you get its type, you get its modifiers, right? And you get the description of what the field is. Notice what you don't get here, though. You don't get the value of the field, which is slightly annoying, actually, right? So even though the field here is 2.7, blah, 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 and pi is 3.14, right? The documentation doesn't tell you here what the value is. If you want to get the value of the field, you have to click on the link, right? Which is actually slightly annoying, but that's the way it works. Okay, every constructor should have a Java.doc comment that describes the purpose of the constructor. Now, normally writing the constructor documentation is pretty easy, right? Because every constructor does the same thing, right? It initializes the state of the object. Right? So for the point2 class, for the no argument constructor, what does it do? It initializes the coordinates of the point to 0, 0. I'll explain what this stuff here means in a second. When you write the comment for a constructor or method, the first word is normally a verb, right? Because constructors and methods, the analogy for object-oriented programming is that these things are actions, right? So actions are verbs. So the recommended way to write the documentation for these things is to start the documentation with a verb, right? So constructors, they always initialize, right? So initializes the coordinates of this point to 0 and 0, right? Now, what does this funny at code inside of braces mean, right? So at code means take that, right? Whatever follows at code, right? And when it generates the documentation for it, it's going to format that using a monospaced font, so a typewriter style font, right? Whoop, oh wait, hang on, okay, here it is, right? So when you generate the documentation for that, notice that the stuff that you write in at code, it appears like that, right? So it appears as though it was a font that you'd use in a code editor, right? Where everything is spaced with the same width, right? Whereas the rest of the text is in a non-monospaced font, right? Proportional font. Which is easier to read, right? So if you want to, and you don't have to in this course, right? If you end up in a professional job where you're writing lots of documentation, it's part of your job to make your code, to make your documentation nice and readable, right? In this course, I don't care if you write at code to offset this sort of thing, right? But if you want to, this is how you do it, right? If your constructor has a parameter, then you should describe what is the purpose of the parameter using the tag @param, right? So that's what the param tag is for, right? So description of the constructor, right? Then documentation for each parameter, right? Okay. So the two argument constructor initializes the coordinates of this point to x and y, right? Where x and y are specified by the caller. It was probably fine just to leave this as x and y, right? So this has parameters, so we document each parameter with an @param tag, right? The name here is supposed to match the name there, and that name there is supposed to match the name there, right? You don't put in any punctuation, right? So there's no colon or hyphen here, there's no colon or hyphen here or period, right? Javadoc will automatically insert a punctuation mark here for you, right? So what's x? Well, x is the x value of the point, and y is the y value of the point. So when you generate the documentation for that, right? Oh, sorry, I have to jump ahead to the detailed documentation here, right? So when you generate the documentation for your class, right, you get the description here, right? And then the parameters are documented here. Notice again, don't put the hyphen in, right, inside your Javadoc, right? So there is no hyphen here. Right, the Javadoc tool will insert it for you automatically when it creates the documentation. All right, and one more example. So this is the copy constructor, right? So what does it do? It initializes the coordinates of the point by copying the coordinates from other, right? What is the parameter other? Well, it's the point that you're going to copy, right? And again, when you look at the documentation that's generated, right, the parameter is documented here. All right, so that's plenty for today. We'll finish up this lecture in the next, on Monday, I guess, on Tuesday, right?